Hey everyone, this note is on Trig Identities Day 1. What we're doing here is going to be quite challenging. So as you're watching, make sure that you write down any notes that you might have and just push through the challenge of what we're doing right here. Once you push through it, this stuff can actually be a lot of fun. And I'll be right there to support you through this as you're working on this in class, okay? Okay, so let's make a list of some basic identities. So cosecant of x is going to be the reciprocal of sine. So because it's the reciprocal of sine, it's 1 over sine of x. Okay, the secant of x is the reciprocal of cosine. So this is going to be 1 over cosine of x. The cotangent is the reciprocal of tangent. So this is going to be 1 over tangent of x. So, and tangent of x also has its own like special identity as well. And that identity is that tangent of x is actually also sine of x over cosine of x. So just a reminder right here that sine of x is always going to be y over r, right? And cosine of x is x over r. So if I do this right here, we know that this sine of x right here is going to end up being y over r, excuse me. And we know that this cosine of x is going to end up being x over r. And then we can actually multiply by r in both the numerator and the denominator to cancel them out. And then we end up getting y over x, which is what tangent is. So that kind of shows you that tangent of x really truly is sine over cosine, okay? And now because cotangent of x is the reciprocal of tangent of x, all I have to do is the reciprocal of sine of x over cosine of x. So cotangent of x is cosine of x over sine of x. Okay, so now let's talk about some Pythagorean identities. So we're going to derive our most basic, most simple identity that we're going to be using when we're looking at trigonometric identities, and that's a Pythagorean identity. Now, before we write this, you're going to want to write kind of small because we've got a lot of stuff to fit into this box right here. So right here, what we're going to do is we're going to start with Pythagorean theorem. Okay, so I'm going to draw a right triangle right here. And we know with Pythagorean theorem right here, it's going to be a squared plus b squared equals c squared. We know that, right? But when we're looking at this like on a coordinate plane right here, so we've got our x and y axes. Remember, this right here is x, this right here is y, and this right here is going to be r, okay? And we also have an angle theta inside of here. So we'll call this angle inside of here angle theta, okay? And so instead of a and b, I'm going to use this y right here and this x right here. So I'm going to say y squared plus x squared is equal to, and instead of the c value right here, we can say that the c value is going to be the radius. So this is going to be equal to r squared. So we're still doing Pythagorean theorem. Nothing's changing. Okay, now I'm just going to divide everything through by this r squared. So this right here is going to say y squared over r squared plus x squared over r squared is going to equal r squared over r squared. Now we know that r squared over r squared right here is going to be 1. And right here, when we do this piece right here, we can just say that this, instead of y squared over r squared, we can just say that this is y over r, and the whole thing is being squared, because if we square everything, we would end up getting y squared over r squared. Okay, and then this one right here, we're going to say that this is x over r, and this entire expression is going to be squared as well. And if you remember that the sine of theta is always going to be y over r, so just a side note that sine of theta is always going to be y over r, and that cosine of theta is always going to be x over r. So right here, this means that this is going to be sine of theta, and that's going to be squared, plus, and this right here is going to be cosine of theta, and that's also going to be squared, and that equals 1. But we don't usually typically write it like this. We write sine of theta is sine squared theta. What this means right here is sine times sine. So sine squared theta is the same thing as sine of theta times sine of theta. Okay? Plus, here we're going to say that this is cosine squared theta, and that's going to equal 1. So here's your first trigonometric Pythagorean identity. So if you take a look at your formula sheet that you guys got, all of this stuff is listed out here. So we've got that tan is sine over theta. We've got our reciprocal identities right here. And now we know that sine squared theta plus cosine squared theta equals 1. Like, we've proven that. Just a quick heads up that this is allowed to be rearranged. So, for example, I can say that sine squared theta is going to equal, if I isolate sine squared theta, I would subtract the cosine squared theta over, so it'd be 1 minus cosine squared theta. And vice versa, I can say that cosine squared theta is going to be equal to 1 minus sine squared theta. So all of this stuff can be rearranged, okay? Now, we have two other Pythagorean identities that we can derive. To be honest, you really only need to know one. Well, I guess you don't need to know any of them since they're on your formula sheet. But let's say you want to figure out what the other identities are. It's all based on the sine squared plus cosine squared theta equals 1. So one option that we have right here is to divide everything by sine squared theta. So I've got sine squared theta plus cosine squared theta is equal to 1. All of these terms are going to be divided by sine squared theta. So I can go through and say that this is sine squared theta divided by sine squared theta, cosine squared theta divided by sine squared theta, and 1 divided by sine squared theta. Well, in this first expression that we have right here, we know that anything divided by itself is just going to be 1. So sine squared theta divided by sine squared theta is just simply 1. Now this is cosine squared theta divided by sine squared theta, and we learned that cosine divided by sine is cotangent, so cosine squared theta divided by sine squared theta would be cotangent squared theta. So over here we can say that this is cotangent squared theta, okay? And then 1 over sine squared theta right here, we know that 1 over sine is cosecant, so we know that 1 over sine squared would be cosecant squared theta. So right here we can say that this is equal to cosecant squared theta. And here's another trig identity, which is pretty much equivalent to this one, but it will be helpful to us as we move forward, okay? And then the last option that we have is to, instead of divide everything by sine squared theta, we're going to divide everything by cosine squared theta. So again, we start with sine squared theta plus cosine squared theta equals 1. And then I'm going to divide everything through by cosine squared theta. So right here, we want to figure out what sine squared theta divided by cosine squared theta is. Well, we know that sine divided by cosine is tan, so sine squared divided by cosine squared is tan squared theta. So here we can say that this is tan squared theta. And then cosine squared theta divided by cosine squared theta, anything divided by itself is 1. And then 1 over cosine squared theta right here. We know that 1 over cosine is secant, so 1 over cosine squared would be secant squared. So here I can say that this is equal to secant squared theta. Take a look at your formula sheet, and those two identities are also written out right here, okay? We're going to get started on proving trig identities pretty soon. And here are some helpful hints that I'm going to always bring you back to when we do some trig identities. And then later on this unit, I'm going to bring you back to this page quite often once you understand what the double angle formulas and the addition and subtraction formulas are, and we'll use those throughout this unit. Okay, so anyways, the first thing that you need to make sure that you always do is you always have to write equivalent statements. You cannot change the statements. And also you have to keep everything on its own side. So for example, if I have tangent of theta, I can rewrite this as sine of theta over cosine of theta. I cannot take tangent of theta
and then like subtract 1 from it or multiply it by something. Like whatever I write down has to be equivalent to the line above it. Is sine theta over cosine theta equal to tan theta? It sure is. So I've written equivalent statements. I haven't done inverse operations or any type of operations like on both sides of the equation. That's not going to be allowed because we're not solving an equation, okay? I would strongly recommend that you change all ratios to sine and to cosine. Now, that doesn't mean that that's the only way to do it, but it will definitely make things easier, especially if this is something that you might struggle with. You have to follow all number and algebra rules. And then the other two bullet points that we have right here, we'll revisit later on, and then try to factor if possible. That's going to be really important, okay? Oh, but also I said we'll skip it, but I do think it's important that we look at these Pythagorean identities as well. Okay, so the question right here says, rewrite each of the following expressions as a single value or a single trigonometric ratio. So at the end, we're going to have equals, either a number or equals sine or cosine or tangent or secant, cosecant, so on and so forth. Okay, so right here, we know that we have secant of x over cotangent of x, but we also know that secant right here is 1 over cosine of x. And we're multiplying that by cotangent of x. And we know cotangent of x is cosine of x over sine of x. And we can simplify this because if I have cosine of x in the numerator and the denominator, they both would divide out. I'm not changing it. I'm not doing any type of operation to change this expression. I'm just simplifying it. And then I end up getting 1 over sine of x. And then as a single trig ratio, we know that 1 over sine of x, the reciprocal of sine of x, is cosecant of x. And I'm done with question number 1.
Okay, in number 2, we want to write this as a single trig ratio. Now I see this 1 plus tan squared theta, and that looks familiar to me. And if I go to my formula sheet, I have right here tan squared theta plus 1, which is the same thing as 1 plus tan squared theta. So we know that 1 plus tan squared theta is secant squared theta right here. So I'm going to rewrite this as secant squared theta. 1 plus tan squared theta is secant squared theta. And we also figured that out right up here as well, okay? And then 1 minus cosine squared theta looks an awful lot like sine squared plus cosine squared equals 1. Now, if I move the cosine squared theta over, then that means that sine squared theta is 1 minus cosine squared theta. So I can replace this 1 minus cosine squared theta with sine squared theta, okay? And then don't forget to bring down your equal sign, and also you probably want to be consistent with the variable here. Sorry about that. This should be x, not theta. So let's go ahead and fix this to x instead of theta. And then right here, we're now going to rearrange everything so that it's in terms of sine and cosine. So we know that secant is 1 over cosine. So this would be 1 over cosine squared x. And then that's being multiplied by sine squared x. I'm going to make this over 1. And then we can just multiply numerators and multiply denominators. So when I multiply the numerators together here, 1 times sine squared x is just sine squared x. And then multiply these denominators here. Cosine squared x times 1 is cosine squared x. If you look at your formula sheet right here, we know that sine over cosine is the same thing as tangent, which means that sine squared over cosine squared would be the same thing as tangent squared right here. So over here, we can say that this is equal to tan squared x, and there's our single trig ratio.
All right, on this one right here, I'm going to change everything into sine and cosine if possible. So I'm going to write down 1 plus, I know that cotan squared x is cosine squared x over sine squared x. And then I'm going to copy down times sine squared x. And now I'm just going to distribute this through here. So sine squared x times 1 is just sine squared x. And then sine squared x times cosine squared x over sine squared x would end up being just cosine squared x. Just writing this on the side. Hopefully you'll see that those cancel out. So you get cosine squared x. And we know sine squared x plus cosine squared x is 1. Boom, done. All right, in this last example, we want to simplify this as well. Sine squared x plus cosine squared x, we already know is just going to be 1. And then secant x is going to be 1 over cosine of x. So then we've got fractions within fractions, but we've done a little bit of practice with this. I can just multiply by cosine x in the numerator and denominator. Remember, by doing that, I'm just really multiplying by, this is what I'm multiplying by. So I'm multiplying by 1, so I'm not really changing anything, right? So then this would be, this cosine x would cancel, and then on top you would get cosine of x, and then that's it. And the beauty of these two, there's multiple ways to do this. There's lots and lots of different ways to do this. I'm not going to show all the different ways that we can do this, but if you can think about this in a different way, then in general, if you can think about the questions that we talk about in a different way, then all the power to you. I could just leave this honestly as 1 over secant of x, and I know the reciprocal of secant of x is cosine of x, and then I'm done. Okay? All right, that's it for this video. Let me know if you have any questions. Otherwise, I will see you in class. Bye.